Hello, a very good afternoon. It's good to go back to get back into presenting our research, our thoughts and thinking, and I'm glad to have Keith today with me here and to present electrical vehicles, social technical as barrier to the UK targeted growth in that area. Let me introduce Keith. Hello, Keith.
Hello, how are you doing?
So we know that a sector is, well, in a fast-moving and exciting world around zero emission transport, electrical vehicle specifically, kind of need different structure, different thinking, different approach in how to do things differently. Now, we are glad to have you on board to explain all of these questions around the electrical vehicle and that kind of passion from the government, individuals, group, companies, all around. Anyway, looking at your bio, I mean, it's so heavy in increase in industrialization, commercialization. So let me go through it very fast. So you are electrical engineering by profession and had many senior position within the UK renewable sectors, including leading solar and energy storage companies focusing on battery energy storage system, which I'm going to have tons of questions for you. I'm sure the audience will do that as well. IoT driven smart energy analytics and rapid charging EV infrastructure. It's really a hot topic these days, and we are very keen to listen to you in a minute. You seems that you work also as experts in commercialization and business analysis of utilizes scaled battery backed EV charging. You've been CEO for global LEV, a light electrical vehicle company, pioneering the transition to groundbreaking lithium powered EV with more than 20 years of experience. Well, I can spend a lot of time in reading this, a lot of achievement through the career. But what we would like to see today is something about your research, your thinking, and your achievement within framed by your experience and knowledge around electrical vehicle. So I'll start the presentation for you, and please let me know whenever you need me to go ahead with clicking.
Okay, well, thank you very much, Salah, for the introduction, and welcome to all those that are online listening to this being streamed at the moment. It's a pleasure to be able to actually present this to you. What I'm going to be talking about today is some of the technical barriers and the social barriers that are hindering growth in EV transportation in general. So this is also part of some very deep research that I'm doing at the moment, and it's looking at some of the major barriers that could be holding us back from reaching the UK's growth target of zero emission vehicles by 2030. Okay, so I'm going to just basically give you a quick background on EVs. Basically, electric vehicles are not new. They've been around for almost 200 years, way before internal combustion engines became first known. So in 1830, the first practical electric vehicle was developed by an inventor by the name of Robert Anderson in this country, of all things. And by 1900, electric vehicles were outselling internal combustion engine cars by a huge margin. It was every two vehicles out of three that were sold in the country in the 1900s were electric vehicles. Now, it died down because petrol became very cheap as a fuel and far more flexible in its approach. So by the 1970s, there was a sudden electric vehicle resurgence And that was primarily down to the increased cost of oil during the 1970s. A lot of political and war-torn factors that increased the oil price. And then all of a sudden it died down again. Most of it was political, and a lot of it was due to the price of oil falling again, making it much more cost effective to drive a petrol engine car. Now, by 2010, there were some major milestones. First of all, the world's first commercialized electric vehicle. A lot of people immediately think of Tesla, but it was actually the Nissan Leaf. And that was the first commercially marketed electric vehicle that was available globally. Still being sold today in its second generation guise. And then there was around about the mid 2015, around about that era, 14, 15, Tesla came onto the market. Their first car was actually built in the UK by Lotus, and it was based on a Lotus Elise, and it was called a Tesla Roadster. And that really was the foundation and the base for a very, very intense decade between 2010 and 2020 for electric vehicle development. Now, if we move to the current year, 2021, there are actually, since did some research into this, there are actually more than 50 new pure electric vehicles on the market. So the selection is immense. They are still quite pricey, and I'm going to be going on to the reasons why prices are going to be dropping on electric vehicles and how electric vehicle infrastructure could create a barrier to growth in the next 10 years. Okay, Stella, thank you. So what is electric vehicle? A few years ago, if you asked somebody this question, they would have immediately said golf cart or a milk float. But things have moved on. We've gone from the 5 mile an hour thing to the car that you can see now, which is the electric version, the Mini Electric, in a typical compact car. That's a Peugeot 2008 family saloon, pure electric. And this is a Jaguar I-Pace, which won the Car of the Year award in 2019, Global Car of the Year award. First time an electric vehicle had ever won it. And that's a 4-wheel drive electric vehicle. And then we look at probably one of the best cars in its class, for sure. And that's a Porsche Taycan, which is 4-wheel drive and does 0 to 60 in around about 2 seconds. Now, I've purposely left Tesla out of this at the moment because their cars don't exactly fit into the traditional areas. But make no mistake about it, Tesla have been instrumental in propelling growth in electric vehicles and also perpetuating the hype. So thank you very much for that, Tesla. We move on to the next slide now. Now, this is basically a cutout of a typical electric car. And if you look at the floor first, we're going to go around clockwise. Most electric vehicles have got the battery packs in the floor, which creates a very low center of gravity for the car. And it's a great way of not taking up too much space in the cabin or the boot. And for any American friends of ours, that is the trunk. Now, if you move along, we have a typical carport, which could be anywhere on the side of the car, the back of the car, or on the Nissan Leaf. It's actually in the decal. The Nissan badge actually becomes the charge port. So there's many varied ways of putting those in. There's 2 kinds of charge ports, which I'm going to talk about in a minute. There's fast charging, and then there's rapid charging, which has now become ultra rapid charging. And then typically the vast majority of electric vehicles are front-wheel drive, and you typically see the electric motor, which is really, apart from the wheels and the axle to the motor, they're the only moving parts in an electric vehicle, which makes it very, very simple to maintain. So that's the transmission for a two-wheel. This is showing you a front-wheel drive car. A lot of the newer cars are going back to rear-wheel drive. So the new Volkswagen ID.3, the motor is in the back driving the rear wheels, as is the BMW i3. So as we move around there, you will see that there's quite a few electrical components that are stuffed into the front section of the car, which would normally be where the engine of a traditional car is. There's numerous things there. There's a battery management system. There is the onboard charger, which converts AC to DC if you're using an AC charger. But it also acts as a step down for DC to DC. So that's got a twofold function. And then there is, up until very recently, there was also a separate battery in every electric car, which was low voltage. Now, the voltage of most electric cars is between 350 to 800. But all of the ancillaries, for instance, the headlights, the instrument panel, the radio, etc., the navigation, they all work off 12 volts. So right up until very recently, there's been a separate 12-volt battery, just like you get in a normal car, which is unbelievable, really, when you think that you've got this huge power pack sitting under the base of the car. So you will still find in electric cars an auxiliary 12-volt battery to power all the essentials. And then if we move along, one thing that a lot of people that are not really delved into electric vehicle technology, that what they don't realize is that there is a huge amount of thermal heat produced by an electric car, especially when it's under load. So for instance, driving up a hill, accelerating past 50 miles an hour on motorway speeds, the battery develops a huge amount of heat energy. And basically there needs to be a way to cool the battery. So the vast majority of cars, there's only two ways of doing this at the moment. It can either be thermal cooling. So in other words, air coming in the front of the car goes over the batteries and cools it that way. Or most common is liquid cooling, which is water with an inhibitor in it. This has been tried and tested over many, many years. A lot of people think it's a bit odd having water going around batteries, but of course they're separate. And it's the most efficient way of reducing the heat in the battery. Now, a lot of electric cars capture that heat, and they use that for supplementing the air conditioning in the winter, for instance, in cold weather, or it can act as a coolant for the heat exchanger. So we move on then. We've already spoken about the DC-DC converter. And then we've got the power electronics controller. And this thing here, not only when you plug the car into a fast charger, the car and the charger have to talk to each other. And there's several protocols, which I'm not going to go into in depth, but there's a protocol which is called CAN bus, which those of you in electronics will be very familiar with. Or there's PLC communication, which, again, those of you into computer electronics and communication skills will know exactly what I'm talking about. Those are the two communication protocols. Unfortunately, it's not been standardized yet. So there are handshake issues sometimes when you plug the car in. And then finally, you can see from the cutout there, we have an electric motor in four-wheel drive vehicles more often than not. For instance, the Jaguar I-Pace, the Porsche Taycan, and the Jaguar the Tesla S, or the Tesla 3 four-wheel drive. They have a motor at the front and one at the rear. And the control of the four-wheel drive is done completely electronically. There's no mechanical differential. It's all done electronically. It's very, very clever. Okay, we'll move on to the next slide now. So there's very, very many variants of electric vehicle. The first one at the top is a pure electric vehicle, which is what I'm concerned with. That's the battery electric vehicle. Next down the list is the fuel cell electric vehicle. Now this is, if essentially, a lot of people don't realize this, but a hydrogen car still has to have a battery electric vehicle as a mule that it bases itself on, because fuel cells, generally speaking, do not produce variable output of voltage. It's normally fixed. So to be able to slow the motor down and speed it up, and to take some of the peaks and troughs of this fixed output, the car has to have a battery modulator in the car. And it may only be 16 kilowatt hour batteries, but it still needs it. So the fuel cell is actually acting as a generator that is constantly charging the batteries. That's how a fuel cell vehicle works. And then we move on to the hybrid electric vehicles, which if anyone ever talks to me about hybrid electric vehicles, I'm not going to be very politically correct here, but it's a bit like being half pregnant. There is no such thing. To me, hybrid electric vehicles, there isn't one hybrid electric vehicle in the world that is more economical than its petrol counterpart, and that's been proved in tests. Despite the manufacturer's wild claims, they are not more economical. And one that's typical of that never lives up to its mileage claims is the Toyota Prius, for instance. So then we move on to the petrol hybrid electric vehicles, and these are ones, it's actually a plug-in hybrid electric. There's a lot of them on the market at the moment. They've got, you can plug them into an AC charger. None of them work on rapid chargers. And the plug-in hybrid electric vehicle typically has a range of between 15 to 30 miles. The more recent plug-in hybrids are around about 30-mile range. So you can run the car on pure electric for 30 miles. Now, for most people, they don't do more than 30 miles a day. So they only use the internal combustion engine, for long runs. That could be a good compromise. To me personally, the battery electric vehicle always wins. It's lighter, it hasn't got a petrol engine weighing the car down. And then we have another type of car at the bottom there, which is basically the same principle as a fuel cell electric vehicle. The big difference is, instead of having a fuel cell, this has a very small electric engine that is basically a generator. It's a petrol engine, sorry, and it acts as a generator as and when the car needs it. So if it runs out of battery, you can run it on the generator, and it charges the batteries as you're traveling along. It's not very green. That's one of the big issues, and of course, it also makes the car much heavier. There's only one real range extending hybrid electric vehicle on the market at the moment, but there is going to be another one coming out this year. The current car is the BMW i3 range extender, but last year they actually stopped producing them. They're still in the showrooms, but they're effectively a thing of the past. Okay. Now, I haven't got time to go into battery technology per se. It's a very, very big subject. But this is just giving you a bit of a heads up, really, on how the battery technology is going to look over the next few years. Lithium-ion batteries now have become a commodity. They are no longer a normal product. They're being traded on markets, believe it or not, exactly the same as gold, silver, steel. They're traded on the commercial markets, the sweet spot that everybody is looking for is $100 per kilowatt hour of battery, and at the moment we're hovering around 150 to 160 kilowatt hours, the cost of a lithium-ion battery. Now, if you go back 10 years to when the Nissan Leaf first came out, the cost of a lithium-ion battery then worked out at $950 for 1 kilowatt hour. That is unbelievable compared with what we're paying for them now. And that is one of the reasons why you're seeing an upsurge in capacity on electric vehicles. So the majority of electric vehicles that you see on the road now, most of them are over 200-mile range per charge. And that's quite enough for most people. If you drive over 200 miles on a motorway, you're probably going to have to stop for a coffee anyway after 200 miles. It's a hell of a journey. And during that coffee break, if you've got a rapid charger, within 30 minutes, you can charge your car up to 80%, and you can be on your way for another couple of 100 miles. So it's not really an issue nowadays. Coming up close behind solid-state batteries, effectively a lithium-ion battery is actually a cathode and an anode, which are actually solids, and the electrolyte is actually a liquid. And then there's a battery separator in between. Solid-state batteries, the whole thing, including the electrolyte, is solid. And it makes for a much more stable, safe, and higher capacity battery. So those are already in the test phase, and we should see the first commercial solid-state batteries come out next year. One thing is for sure, that those batteries are not going to be cheaper than lithium-ion at the moment. It's all about economies of scale. But watch this space. The next thing is supercapacitors. Now, these have been out for many years. If you can just go back, please, Salah. Thank you. Yeah, supercapacitors are effectively giant capacitors, which are not power dense, but they are very, very good at releasing energy in split seconds. They do not degrade like a battery. A lithium-ion battery has got around about 1,000 to 2,000 cycle life before it starts losing huge capacity. A supercapacitor never ever loses its capacity. What they're trying to do at the moment, some researchers are trying to combine supercapacitors with the next generation of battery, which is graphene technology. I suggest that this is a very, very interesting technology. I suggest, if you're interested, to look this up on the web and just read about it, because this is where you can start building batteries into the body of a car or into the body of anything that you're building. So you're no longer constrained by the size of the batteries. This is flexible technology, much higher density than a lithium-ion battery or even a solid-state counterpart. And this is going to be very, very, very interesting. So what about hydrogen? That's a very good question. The problem with hydrogen at the moment is there are safety concerns, obviously. You'd effectively be sitting on a tank of very high-pressured compressed hydrogen when you're driving a hydrogen car. That's the one thing to think about. But there's safety concerns, of course, in distribution and storage of the hydrogen. What happens if a hydrogen car is in a crash? Obviously, all these things are being addressed at the moment. But the most important thing is that it takes, for every kilowatt that a hydrogen fuel cell can produce in hydrogen, 1 litre costs, it takes 6 kilowatts to produce 1 kilowatt of power at the moment. It's very, very inefficient. And all hydrogen in the UK and most other countries is heavily subsidised at the moment. And we're looking for the holy grail where hydrogen actually will end up being cheaper than the base price of the power that's used to extract it from either water or the air. So hydrogen is not that green at the moment, despite the hype that surrounds it. Another thing is compressed air. So instead of having a hydrogen tank, you can highly pressurize a container like a hydrogen tank with compressed air. And the compressed air, just like it uses, you can use drills and tools in a workshop with compressed air. This thing will drive the wheels. At the moment, they've not got the efficiency of a compressed air car working that well. You have to stop every 20 miles to fill it back up with compressed air, so it's not that good. And the future is still going to be lithium-ion batteries, but I'm going to be talking about some of the innovation that's actually here now in the next few slides.
Maybe we need to speed up a little bit with the process because the time is clicking.
So electric motors. There's several different types of motors in electric vehicles. The most common originally were DC motors, mainly brushless. But now most electric cars use AC motors. So the DC that's stored in the battery is converted to generally square wave AC, three-phase, and that drives a whole host of different types of motors. You can see the first one, the asynchronous induction motor, is generally found in the Tesla. Brushed, externally excited synchronous motors in the Zoe, and Nissan Leaf and the Tesla 3 are the new brushless permanent magnet motors. You can see more about this on the web. So some of the key factors of electric vehicles, of course, zero emission at the tailpipe. Most new EVs are more than 90% recyclable. The new Volkswagen ID3 that is produced, as well as the BMW i3, completely zero carbon. The factories are zero carbon, and they've offset the transport from the factory to the customer. Battery recycling is a thing of the present. It's not a thing of the future. All batteries in EVs now can be recycled to a second and third life. Most batteries come with a minimum 8-year warranty, so you haven't got to worry about that. You know, a lot of people think, well, my phone battery, I've got to get it replaced after a year and a half. That's not the case with the battery management systems that look after the batteries in EVs. Okay. Great. So charging infrastructure is one of the most important things that is going to reduce the barriers to growth within the EV market. So one of the most important things is where the charging stations are located. At the moment, they're located where there is a grid supply that's got capacity. I'm actually researching at the moment into areas that can overcome that by using grid scale battery energy storage systems to back up where a grid is compromised. This will back up the grid. We've already spoken about sometimes there's handshake issues when you're plugging in a charger. So the charging communication protocol, of course, that varies from PLC and CAN bus, and that's something that's got to be addressed. The rapid charger deployment at the moment are generally on A roads and motorways. So we need to start seeing a lot more in city and town centres. At the moment, generally speaking, everything is conductive charging. In other words, you use a cable and the connector of that cable is plugged into the car using conductive charging. Inductive charging is a bit like your phone, where you can use a wireless charger. It's very simple to use inductive charging with low current devices such as a phone. But with cars, it presents a lot more problems with the high current that's required. And that's an ongoing thing at the moment, where you can park up over a plate and the two plates will meet and you can charge your car inductively. It's not as efficient as conductive charging. Conductive charging is around about 98% efficient. Inductive charging at the moment is around about 80 to 82. So there's a few losses. Vehicle to grid. This is where you use your vehicle as a generator in peak times to support the grid, and you can sell the electricity back to the grid. And vehicle to home is exactly the same principle, where you plug your car into your charger, and peak times, when you're paying a lot of electricity at home, your car can supplement the grid and cut down your electricity costs. You charge your vehicle at night using cheap electricity. That's the philosophy behind it. And the future, who knows? That's another subject. Okay, next slide, please. So we've already got a glimpse into the future. This is a Volkswagen ID.4 that you can see in the background there. It's not released at the moment. And I've actually seen the robotic charging units. This is mobile. What happens is you drive into a parking spot. As soon as you enter the car park, you've got a parking spot that you go to, and this robot, which is a rapid charger with a battery pack on the back. So the two sections, one is the charger, one is the battery pack. This will actually come up to the car. It knows exactly how to get into the charger, plugs in while you're sitting in the car, and in around about 10 minutes, it will give you a 50% boost, and off you go. So robotic charging is a thing of the present. In the future, the rapid charge is going to be even faster, and it will be literally a matter of minutes, roughly the same time as it takes to fill up a normal petrol car. So that's where we're moving to. Can I have the next slide, please? Thank you. So things like barriers to growth in the past have been range anxiety. That's not so much of an issue now. It's an issue for people that don't own an electric car. But once you've owned an electric car, I can assure you it is not an issue. Your driving habits change. I'm doing some research at the moment on investigating charge point trauma. So this is where charge points effectively cause the EV users huge issues. And one of them is where you can't get the handshake to work properly on the car. You could turn up at a charge point and it's out of operation. So there's a lot of issues on that side of things. Then they're also not covered by the same uptime regulations that a petrol station is for. So if you close a petrol station for more than 30 minutes, you will get fined by the regulator that looks after that part of the government. There are no regulations at the moment on chargers, so a charger can be out of action for a week, and this is something that I'm working on. They need to be where the user needs the charging points, not where the grid dictates. And as I said, I'm working on some research that should solve that problem. At the moment, the battery price dictates the electric vehicle price, and I've already explained that the prices are coming down, and we should see price parity between electric vehicles and internal combustion engine cars around about 2023. Having said that, the new Volkswagen ID.3 is the closest that we've got. The base level ID.3 is roughly the same cost as the base level ICE equivalent, which is the VW Golf. At the moment, there are two main rapid charging connectors, and that is gradually moving to one, which is called CCS. It's a European standard that's going all over the world now. That stands for Combined Connector Service. And then lack of used EV stock is a big issue at the moment because it's such a new technology. You can't buy, there's not that many available EVs on the used market. Okay, next slide, please. Okay, now there's a lot of talk about can the grid support future EV growth, but the fact of the matter is that most EVs, more than 85%, are charged overnight at home or on the street. So EVs will will balance the demand curve. So where we used to get peaks, we used to get big dips at night, and electricity is being produced with nobody using it. All of a sudden, we're going to be starting to use that. It's going to be far more economical for the generators. And the consultants, McKinsey, have also confirmed that they've been doing 3 years research on this, and they forecast no increased grid demand. I think the word that's missing from there is significant. And eventually, some of the work that I'm working on at the moment, EV charging stations, dedicated EV charging stations, will use battery energy storage systems to support them. Okay, next please. So, this is just food for thought. A litre of petrol uses 6 kilowatt hours of electricity to refine on average. Now, whenever anyone compares petrol to electric, they never ever take this into account. 6 kilowatts of electricity, compare an EV for 23 miles or 37 kilometers. 6 kilowatts of electricity charging an EV at home would cost around about 48p, so it's less than 50 pence for 23 miles. A litre of petrol is currently 118 per litre. Actually, it's gone up since I wrote this a few days ago. It's now around about 120. So the fact of the matter is that petrol not only pollutes our environment, but it's also roughly 2.5 times more costly to the end user. Okay, very briefly, these are common EV myths. EVs have no power compared to ICE vehicles. Try telling that to the Porsche Taycan and the Tesla S. 0 to 60 in 2 seconds or more. The fastest car per se in the world at the moment is actually an electric vehicle. It's not petrol, it's not diesel, it's electric. Now you can't, a lot of people, you can't use an EV in a car wash. Rubbish. Of course you can. EVs and chargers can't be used in the rain. Another myth. EV batteries have a short life. Well, there are there's been a lot of research done in this, and a lot of Nissan Leafs, for instance, are now in their 10th anniversary, and they're still operating at around about 85% capacity. Nissan have stated publicly that they have never had a battery fail in a car unless it's been damaged. So, you know, they've gone over a pothole or something. EVs are completely safe. In fact, they are much safer now than a normal ICE vehicle, especially in a collision. EVs, of course, can be used for long journeys now. There's rapid charging is spreading across the country, and it's doubling year on year. So that's not going to be an issue anymore. EVs are more expensive to run. Well, they're 2.5 times cheaper at the moment than a petrol car or a diesel car to run. And they're much cheaper to maintain. A lot of garages are starting to get worried because the actual man-hours time to maintain an electric vehicle is very, very low compared with an ICE vehicle. Next slide, please. So is it the right time to buy an EV? Well, yes, it is. It's better for the environment. We've got no pollution at the tailpipe, ultra low maintenance costs. And one thing that I've not talked about is the regenerative braking. Now, most new EVs use regenerative braking. And effectively, when you take your foot off the pedal, off the accelerator, the motor electronically brakes. So because there is there's no contact between the brake pad and the brake linings, there is far less fine particulate matter that affects people, for instance, with asthma. So that's got to be good. We're approaching price parity with the ICE models. An electric car, whether it's a small or large one, will give you far better performance than the equivalent petrol car. That's a massive plus. And running costs roughly 1/3 of conventional cars. So next, please. So this is the future. You can see roughly in the middle there, this is obviously a mock-up, but the lane you'll see above a sign above, which is electric vehicle wireless charging lane. And this is already, they've been testing this in both the US and Germany. And in Germany, they've actually got a brand new motorway that's been made on a test track that is purely wireless charging. And they're actually working on enhancing the wireless charging so they can improve the efficiency of it. But that is very, very close to becoming a reality. And you will pay per kilowatt hour as you travel along the road. So you no longer have to worry about range anxiety when you're on a long trip. And the next one, please. So the future is now. So anyone that says that they can't afford an electric car, they need to think again. This car now is becoming available in this country. In Europe, it's around about €5,500. It's only got a range of between 40 to 50 miles, but for around town, that is more than enough that most people use. It plugs into a normal wall socket. If you look at it, the front of the car uses exactly the same panels as the back. It's made at a price. It's a two-seater, and that's it. And finally, if you want further information and guidance on electric cars, I'm going to do my sales pitch here. This is my latest edition that you can buy off Amazon of Electric Cars, the Ultimate Guide. And that will go much deeper into the technology, the history, and the buying side of things. So I'd like to say thank you very much, and I look forward to any questions, please.
Right. I think we have a lot of questions in here. However, I think we already moved in time. We exceed our time. Just things to mention here, to be honest with you. From computer science perspective, I can see there are a lot of aspects in there where we need computer scientists to study the protocols of handshaking, to look at the softwareization of the car. And then from engineering perspective, we look at the aspect of the control, the aspect of energy generating, and also monitoring the energy consumption, where to have it and how to have it. So it's kind of a mixture, very nice mixture of different approach in these electrical cars. And I can see yourself move nicely, smoothly from the design of the car into the battery and the challenge around the battery, and also the thinking into that. So a quick question to you. You've been advising to have more to have an electrical car and so on. But through your research that you are doing, what you have achieved so far into these barriers, and any, I would say, points to share in here?
Yes, I carried out some research with 282 EV users, precisely, around about a year ago. It was just before lockdown, fortunately. And we asked simple questions to each of the EV users. It was a structured questionnaire, so it was much easier to monitor and to analyze. And the outcome was that most people, which confounded some of the critics, most people, the overall average response was that most people were very happy with the range of their electric vehicle. They specifically bought the electric vehicle knowing full well what the range would be, and it suited their needs. So if they were doing long distance traveling, they would probably buy a Tesla S or a Jaguar I-Pace, which has got over 300 miles of range. If it was for around town, they just bought something with a smaller battery that was cheaper to purchase. So that was one of the interesting things. But almost all of the respondents came back with the location of these rapid charge systems was always an issue. It was never en route where they wanted the charger. Or if it was en route, they could turn up and a petrol or diesel car was parked in a bay for electric charging, or the charger itself was out of operation, and there was no way of contacting the owner of the charger. So there was there was more negatives, not on the range, and overall people were really, really happy with their car. And 92% of the respondents said that they would never go back to a petrol or diesel car. So that's interesting. But the actual day-to-day experience of rapid charging, which is what I focused on, was disappointing for most people. There are measures underway to address that, and even today there was an announcement from the government that they're putting in several £1 million to improve rapid charging on main trunk roads and motorways. So that's actually a great thing to happen, and I think that's going to help a lot of people in the future.
Great. So I would say thank you so much, Keith. It's a lot of questions in there, a lot of knowledge, information. We definitely are going to look at it around. And once again, thank you so much.
Thank you very much.
By this, we end up our talk here. Thank you.
Thank you.